The way bubbles vibrate and interact with sounds can be exploited by humans too.
Now then, I have here
This is Professor Tim Layton, my scientific mentor and probably the world's foremost expert on bubble acoustics, the relationship between bubbles and sound.
Cold water doesn't clean them.
And what he's about to show me is, well, it's almost like magic.
Here we have a device that we've built. It's a black cone. You could fit it on the end of a tap or in a portable on top of a fire extinguisher or something. And just cold water is coming out of it.
This is an experimental rig which, thanks to bubbles, could one day completely change the way we clean things.
Lipstick is notoriously difficult to remove because it's designed to be sticky. And if we take this sort of Northern kitchen towel and we were to say, right, I'm not very good writing with lipstick, say B, B, C on it, okay, like this. And then we hold this into the stream of cold water. As expected, it stays on. It's really good at sticky.
Now, with a flick of the switch, the magic happens.
And here we go.
It's stunning. The difference is amazing.
This incredibly effective way of cleaning relies entirely on bubbles and their relationship with sound.
Water comes through this device and we add microscopic bubbles and we had ultrasound using this silver sound source at the back. And when the bubbles hit the device to be cleaned, the ultrasound hits them and turns these bubbles from nice little balls of gas into quite excitable little scrubbing machines.
This works because the bubbles are resonating, vibrating in response to ultrasound, the high-frequency sound waves that are travelling through the water.
The wall is shimmering and moving very rapidly with thousands of tiny little ripples. And at the edge of those ripples, you have very high shear in the water. And so what that does is it scrubs away at any surface.
So shear is like this sort of action.
That's
so
right.
Scrubbing.
Yeah, so it's scrubbing. So it really is scrubbing away at the surface, cleaning away, removing dirt and particles. So the bubble wall shimmers to clean, but specifically using the bubbles in this way, they're targeted to seek and find crevices and cracks and clean the dirt out of those.
This is the second really clever bit. The vibrating bubbles send out sound. This echoes off nearby surfaces, and the reflected waves pull the bubbles closer to those surfaces and into any tiny cracks that exist. Those crevices are exactly the places that are usually hardest to clean.
So it's really strongly attracted into that crevice, and it burrows into it, keeps burrowing, digging out the dirt as it goes because its surface is shimmering.
And what sort of applications has this got out in the real world?
We're looking at, first of all, manufacturers with production lines, with big plants. Right at the other end of the scale, we would like to see one of these in every home and every hospital so that hands, scalpels, endoscopes and anything else that you want to clean is safely cleaned. And not only that, but cleaned using cold water with very little additives so that you're not wasting water and so that you don't incur the energy bills and the clean-up bill to make that water drinkable after.
And all that is possible because of tiny bubbles that we can't even see.
Exactly.
So we're going to